Hey everyone, and welcome to another episode of CETV. We are graciously hosted by the Cloud OnAir team. They run these amazing technical webinars every Tuesday, so make sure you continue to tune in and watch those. Today I'm super excited because we have two of the hottest topics in cloud, big data and machine learning. And to help me with that, I have one of the amazing Google Cloud product managers, Abhishek, with me. Abhishek, would you mind introducing yourself?
Thank you, Nick. Hi everyone, I'm Abhishek Kashyap, and I'm the product manager and very delighted to be here and talk to you about BigQuery ML.
Awesome. Yeah, so big data, machine learning, for any of you out there who are playing buzzword bingo, now's your time to bring out those scratch cards because I think that we'll be highlighting some pretty exciting stuff going through. So in order to start talking about BigQuery ML, I think we should at least first cover what BigQuery is. So for any of you who are unaware of what BigQuery is our fully managed enterprise data warehouse solution. It essentially provides enterprise features and functionality for those real-time SQL queries that you need to run. It's pretty unique because it has Google's unique back-end architecture of separating compute and storage, so that as you scale up your compute environment, as you scale up your storage environment, basically everything is completely seamless to you. All you see as the end user is you upload data to BigQuery, you hit the giant big red button that says Run Query, and you get some results. And the other amazing thing is that because it's fully managed, Google takes care of your encryption, takes care of the reliability, the availability, all that stuff, all that typical heartache and heavy weight with managing clusters, all that kind of stuff. So we take that burden off of our users. So Abhishek, since we're going to be talking about BigQuery ML, why are those two topics related? Why big data plus machine learning?
The two topics are related because if you think about where the industry is going, there used to be a lot of historical analysis of data.
Okay.
If you look at the journey of analytics on data in a data warehouse, everyone used to clean the data, process it, build dashboards, and present to executives and make decisions based on those.
Sure, yeah, that makes sense.
But all these decisions were based on historical trends. Mm-hmm. As we see the advent of machine learning and machine learning at the scale to work on terabytes of data, all these decisions could be made in a predictive way. So rather than using somebody's wisdom on what's going to happen tomorrow, you could actually have machine learning applied to every decision that gets taken. And the way we see this manifesting is, just like BigQuery made it very, very easy to go from having to manage your clusters and the node size and the performance to only thinking about analysis and writing SQL to do the analysis.
Yep.
We believe machine learning should be the same way. You should not have to think about the underlying infrastructure. Okay, how many nodes do I need to provision to build a machine learning model? Or do I need to split my data into training and test?
Yeah.
Yes, you always should. So what if we automated all of these and built the machine learning foundations where the data is, which in our case is BigQuery.
Awesome. Yeah, that's exciting stuff.
Yep.
Yeah, so I'm a little bit curious, how have customers previously used BigQuery plus machine learning in the past?
So if you think about a typical process, since it's really hard to do machine learning where the data is, the first step is people end up exporting data to an object store.
Okay.
And from there, if you are a data analyst, you would take a small sample to sheets, do a linear regression. You have an idea to improve the model. You go back, export more data, and do it all over again.
Yeah.
If you happen to be a data scientist, you can take your favorite Python framework and convert the data into frames that framework takes, build your model. To improve, you go back and get more data. So that's the process that you follow, and it takes hours and days for each iteration, just because of the backend work that's needed.
Yeah, I can see an issue just not only for time, because it takes time to obviously export the data from BigQuery, import into GCS or whatever your framework is, but also you're starting kind of a bad trend of creating data silos. You have multiple data sources that you have to manage. If you're updating your BigQuery data set in real time, now you have to somehow get those over to the GCS buckets. So I can definitely see it as a big challenge.
Yeah,
so
and
how are we kind of running into those issues, and how are we dealing with those?
Yeah, and actually to those point, it's actually okay to have silos in GCS. We have seen data scientists having silos on their laptops.
Okay.
People did build models on their laptops.
Fair point.
And then they share with each other using email and SCP. So that's the extent of the silos that are being created with the current processes.
Okay. And so these challenges, how are they typically affecting companies?
Yeah, so the two challenges we see are, one, most companies do not hire enough data scientists. And it's not that they do not want to. If you just go a simple search on LinkedIn, you'll find that there are maybe up to 1 million data scientists.
Okay.
And if you think how many of those million can actually go ahead and write here best-in-class neural network, that number is probably 1/10 of that.
Yeah, makes sense.
And if you start thinking, well, I need to do reinforcement learning, that's probably thousands of people. So the first problem is, if you are going to have so few data scientists, there is no way that you can apply machine learning to more than 2, 3, 4% of the business problems that you deal with. The second problem is, as I walk through the process, it takes a good 6 to 8 hours in just setting up the infrastructure, even if you know what you're doing, to build your first model. So iterations actually take a lot of time because you have to set up 5 tools, set up data transfer, you have to set up conversion of data from one format to another. And that's actually a big productivity inhibitor.
Yeah, that makes sense.
And that's what we are trying to fix. So we launched a BigQuery ML in beta in July at our conference in San Francisco. And it allows you, anyone who knows SQL, to do machine learning just using SQL without having to learn Python or R, and within BigQuery. So you do not have to move the data out either. And that's what BigQuery ML is. It is simply machine learning using SQL in BigQuery. And it actually makes ML accessible for all audiences.
Yeah, that's a good point. So in Google Cloud, we have kind of different paradigms of machine learning. So on one side of the spectrum, you have the ML APIs, you have AutoML. On the other side of the spectrum, you have full customization with the Cloud Machine Learning Engine. And so it seems like this is a good middle ground because machine learning is incredibly transformational across all of our customers. I mean, I've seen and heard some really incredible stories. And so I feel like what we're doing as Google is empowering all sorts of users, whether you're a developer, a back-end engineer, SRE, SQL developer, all these kind of groups and users now have the power to bring machine learning to whatever it is that they touch. That's pretty awesome.
Yeah, exactly. So if you think about what's needed to have machine learning be pervasive across organization, we believe democratization is what's needed. You need to build tools for people and have them use machine learning where they are. You cannot expect that your developers to data analysts to data scientists, all of them will pick up Python and R, and they all will be a data scientist. Rather than doing that, we believe we need to provide tools. So anyone can build a machine learning model. And BigQuery ML specifically targets the gap where you have these data analysts who understand your domain, who understand the data, but they do not have the tools to build a model. So we have TensorFlow for data scientists to build the state-of-the-art model. We have AutoML, Cloud ML APIs. So developers can just call an API on standard problems like object detection. But there's a big gap in terms of you have your custom data, custom business problems. Data analysts are the only ones who understand it deeply. And they can now start using machine learning using BigQuery ML.
That's awesome. Very exciting. So how does it really work in an end-to-end picture? How does it look for the end users?
Yeah, so if you think about an end user. The end user can now just log into the data warehouse or go to a notebook or wherever they are writing SQL. Stay in SQL to build a machine learning model. Stay in SQL to train the model within BigQuery. So you actually bring ML to the data rather than taking data to ML.
Okay, that makes sense.
And finally, I'll show you in a demo just with a couple lines of SQL, which is machine learning specific. You can build a model. So you do not have to worry about hyperparameter tuning, basic feature transformations, which are needed for almost every machine learning model you build.
Yep. And I'm curious, what kind of customers are using BigQuery ML? And do you have any example use cases that you can share?
Definitely. So we usually run a private alpha before we launch a beta. And we had a very successful alpha. These are some of the public references who agreed to share their use case. I'll start with Hearst newspaper. So media companies are usually spending a lot of effort on reducing churn. And in their case, they wanted to start doing predictive churn modeling to do much marketing campaigns to people who are more likely to churn, as an example.
Sure.
To do that, they started working with BigQuery ML. They managed to write their first churn prediction model within a day.
That's awesome. That's impressive.
The model actually combined data from 6 different sources. And since this was SQL, they were able to do the join, staying in their SQL platform. And post that join, they just built a model in BigQML. And then they set up a pipeline using Cloud Composer to do retraining and do predictions, and to have a dashboard that drives the marketing campaigns. And they managed to finish the whole process within a couple of sprints. So that's what they got by using BigQuery ML. 20th Century Fox, they actually introduced a product in our keynote demo. They have a lot of business decisions that they make on top of the recommendation system they have, which is actually a pretty state-of-the-art TensorFlow recommendation system. But the business decisions are things like, okay, which audiences should be marketed to? Which movies should we greenlight? And having those actually takes up a lot of data scientist time, which, like everyone else, they don't have a lot of.
Sure.
So they use machine learning in BigQuery to build classification models to decide which audiences are more likely to watch an upcoming movie and market to them accordingly.
Okay.
Similarly, there are other companies who have used it for a variety of different use cases where they had a lot of data in BigQuery, but they did not want to go through the process of exporting it and setting up multiple tools. And they did not have enough data scientists to have working on every problem that they need to address.
Yeah. So the trend I'm hearing is not enough resources in terms of people, analysts, data scientists to crunch through massive amounts of data. And that data is oftentimes complex, but not only that, it's spread across multiple data sets, multiple tables, and we're allowing them to perform joins to combine this data into one machine learning model that gets built. That's pretty exciting. That's cool.
Yep.
Awesome.
And that's what they all are doing.
Cool. And I hear that you have a demo for us, so I'm definitely excited to see this in action. So what is this demo going to be walking through, and let's get to it.
Yep. So if you imagine a typical scenario, which is you have data about your website analytics coming in, which is Google Analytics 360, and if you have, say, revenue data coming in, a lot of our customers actually join across the two to make marketing decisions.
Sure.
But the typical output of this join, as I mentioned earlier, is just a chart on a dashboard. What BigQuery ML allows you to do is to actually build a machine learning model to do predictions. And since this is part of the BigQuery API, you can actually use these predictions to both connect to your action systems, which in this case could be email marketing or ads, and to directly add it to the dashboard of your choice, because BigQuery works with almost all BI platforms that are out there. So you can do both, because this is already in the BigQuery API, and our customers already have the setup of downstream systems. And it makes it very easy to add machine learning to it.
Fantastic.
And to go to the specific demo scenario, what we did is we have public data set from our Google merchandise store. That's in BigQuery. You can actually go browse it. And if you are a marketer at any online, if you sell anything on your website, what you want to do is you want to track visitors to your website and remarket to them, to have them come back and purchase.
Yeah.
Now, this is a fairly standard problem. The issue is that for the Google merchandise store data, we see 0.7% of the people actually came back and purchased.
Okay.
Now, if you are a marketer and you know less than 1% are going to come back and purchase, if you blanket market to all of them, it's highly inefficient and it's not going to lead to as good a conversion. So what if you could predict who's going to come back and purchase and who's not? And that's what the demo is. And I will...
Other direction.
Okay. So this is the new BigQuery UI that we recently launched. And you can see, I'll make it bigger, that this is a SQL statement that's getting data from
Okay, the public data set.
the public data set.
Yep.
And we have data from 1 year. So we take 9 months of data for training. And we'll keep the last 3 months to test to show you how the model did.
Okay, to verify that's actually working. Okay.
And what we want to predict is if somebody will come back and purchase.
Sure.
So all we need to do for that is say if someone visited and there was a transaction and this wasn't the first visit, then it's will buy later is true.
Okay.
And that's what we'll try to predict. We select some usual columns like where did the person come from, how many pages did the person view, which country, which medium, which operating system, and just throw them in as features.
Okay.
And
sure.
see what happens.
So the machine learning model is going to be built off of these features that you're specifying in the select statement. Okay,
Exactly.
cool.
Yes.
That makes sense.
Then the only machine learning we need to do is on top of the select statement that everyone knows how to write, you just say create model. You give it a name. We are predicting, which is the labels, if someone will come back and purchase. And this is a classification model, so we use logistic regression for this.
Okay, and question on that. So for this use case, we're specifying a logistical regression, but what are the other classification models that are supported?
We have started simple and most useful with linear regression and logistic regression for forecasting and classification. But to your point, we are going to add a lot more models for different use cases pretty soon. And we want to get to a point where you don't even need to decide which model to use.
Oh, okay.
We can decide it for you.
So we can use machine learning to then pick the accurate machine learning model.
Exactly. Yes, exactly.
I love it. Feel like Inception.
There was a survey by Kaggle last year that actually showed 65% of the models written by data scientists are still logistic regression.
Okay, that's pretty large.
So logistic regression actually does capture most of the use cases which are out there.
Okay,
and that's what we have seen with customers. So all I need to do is execute this query. This will take about 3 minutes to build on 22 gigs of data.
Okay.
But what we did was we went from there to test on the last 3 months of data because we knew who came back and purchased.
Sure.
We scored the list based on the model. There's a function called ml.predict.
Okay.
And then we just plotted that list according to the score, according to the likelihood of them coming back and purchased. And what we found was that if as a marketer, you only marketed to the top 6%, 6.5% of them actually came back and purchased.
Oh, that's a lot better than the 0.7%.
Exactly.
Yeah.
So,
okay. That's
so
pretty
our
transformational.
predictions are actually fairly accurate.
Okay.
And more than that, as a marketer, you are concerned about recall. You actually still would capture 50% of the return buyers.
Wow.
So with just saying create model and giving it a name,
Yeah.
we actually have a model that's this good.
That's
And
impressive.
if you want to just look at some of the evaluation curves, which we plotted based on the data from our model, these actually look really good.
Yeah.
Right?
Yeah, that's fantastic.
If you showed it to a data scientist, I'm pretty sure they are going to approve this model.
With pretty much 2 lines of code. I mean,
Exactly.
you have the standard SQL statement, and then you just build model on top of it.
Yes, exactly.
That's impressive. Very cool. And I think we should highlight on one specific thing. Oh, sorry. Actually, go back. I think we should highlight one specific thing was that you built this model. I mean, with two lines of code, and this is pretty advanced. I mean, you have quite a few capabilities. So, would you mind touching on that?
Yeah, definitely. So, if you think about it, this model did not ask you to set up an infrastructure to train.
Yep.
We leveraged BigQuery, and we just created as many processes as needed to build this model for you. And this is going to work on a petabyte of training data, if that's your use case. Because you never have to think about the infrastructure, and BigQuery today can query a petabyte fairly easily.
Yeah.
Secondly, there's a hyperparameter for this called learning rate. We auto-tuned it. We know that you should not be overfitting. So if your data is large enough, we automatically split it into training and test.
Okay.
We do a random 80-20 split, which is the most common. Numeric features should never be put in as is, so we standardize all of them.
And I'm curious about that. Why shouldn't we be using numeric features like dates and stuff like that?
So with numeric features, if their scale is fairly different across 2 features, then one starts dominating over the other. Let's say one of the features is weights in pounds, and one of the features ends up being distance, and the distance is up to 2 miles or 2 kilometers. Suddenly your weight will be a dominant feature.
Gotcha.
So you don't want that to affect. Similarly, if one person builds a model using weights in kilograms and one in pounds, your model will start looking different.
Okay, that makes sense.
So you want to standardize your numeric features, and models work with numbers. So let's say you have string features like categories or booleans. So categories, you cannot just feed in X, Y, Z. We automatically one-hot encode them to convert them to numbers. So these are some of the basic things that we do which enable getting to such a good model so fast.
Cool.
And if you are an advanced user, you know more machine learning, you can use L1, L2 regularization. You can select how to split your training and test data. So if you wanted a date-based split, or if you wanted a different split than 80-20, you can specify all those. And finally, you can set your own learning rate as well. The philosophy that we have is everything that gets to a better model is going to be automated. And things that allow the power users to get to a better model, we'll provide them as options. And that's what we are doing. So you can always just write 2 lines of SQL and get to a really good model.
That's fantastic. We've obviously showed how simple it can be, but how about some of the more complex features, some of the more complex aspects of the machine learning? What do we support from that perspective?
Yeah. So we support creation and prediction using the model from standard SQL. You can use UDFs within. We are starting with 2 types of machine learning models. We'll add more with time. But to evaluate how the model did, we actually have evaluation functions, which give you ROC curve if it's logistic regression, or specific stats for linear regression.
Okay.
We allow you to inspect the weights to see how much a feature impacted the prediction. And finally, we have table valued functions, so you can also analyze your features to see how they were distributed. Because that's something that's very useful during feature engineering.
Yeah. Yeah, I know that can be a little bit complex and involved, especially from the TensorFlow side. So,
Exactly.
It seems like we simplify this, but still give you the ability to kind of do some tuning and all that. That's cool.
Exactly. And let's see if the model finished.
Yeah.
So it did finish
Okay.
in 3 minutes and 12 seconds.
Okay.
And if we just go to the model, what you see is some basic model details, when they were built, what type it is, what the loss type was. We use iterative gradient descent, so it shows you what different parameters were chosen.
Okay.
And if you look at the stats, it will show you the loss stats for training and evaluation data, and the learning rate and how much time it took. Model schema shows you the different fields we used as features
Okay.
and their types. So these are the ones we had in the select statement. And we are going to add more charts here, so you can start looking at curves and precision recall, etc.
Oh, awesome. Within the UI itself.
Within the UI itself.
Cool.
Yes.
That's going to be useful.
And for now, you can actually look at it in Data Studio directly off of BigQuery.
Oh, okay.
So that's it. So we got a model built on 22 gigs of data.
Took 3 minutes,
3
2
minutes.
lines of code.
No
That's
machine
powerful.
learning.
Yeah, no machine learning experience required. Cool. And I think one thing that we kind of touched on that we should emphasize is BigQuery is one piece of the entire Google Cloud kind of data pipeline strategy. So before data gets into BigQuery, you can perform ETL, maybe through Dataflow. You mentioned Cloud Composer, so you can compose like how things are being run in terms of like jobs and when jobs start, when they end, et cetera. And then finally, the data that's being stored in BigQuery is typically in a tabular format, so lots of rows, lots of columns. And a normal human being might not be quite as good at actually plotting those data points out if you have thousands, hundreds of thousands of rows, who knows. And so the amazing thing is that BigQuery is already integrated into quite a few business intelligence dashboards. So this data can already be plugged into sources like Data Studio, Tableau, Looker, et cetera. In fact, one of the really awesome use cases that I recently read is from Tableau, where they took some of the public data that's out there on home prices in Seattle, and they ran a BigQuery machine learning model against it and identified what would a home cost if you want 2 bedrooms, 3 bedrooms, if you want that fancy waterfront view or in town, square footage of the house. I mean, it's pretty transformational, and it's exciting that you can build something that's quite comprehensive from just a couple lines of code, spending a couple minutes. It's pretty exciting. So that's really cool. And go ahead.
Yeah, so as a user, if you log into the dashboard, you can manually type in these fields.
Okay.
And it will use BigQuery ML in the background to get you the predicted prices.
Cool.
So it's fairly interactive, and that's what you need to use a BI platform for.
Yes.
Anyways.
Exactly. How to drill down from the massive amounts of data into something a little bit more meaningful. Cool. And I also hear that Looker has some specific integrations with BigQuery ML. So maybe you can touch on those too.
Yeah, definitely. Looker, we have a deep partnership with, where they have integrated BigQuery ML to their markup language called LookML. And you can actually create a model staying within Looker.
Okay.
Without actually having to go and write SQL.
Oh, okay, without getting into BigQuery and writing a SQL statement.
Yes.
Cool.
And on top of that, some of the evaluation charts I showed, they have built some templates for those, what they call Looker blocks. And they have operationalized the whole ML workflow. So Looker customers can actually start using BigQuery ML through their native integrations as well. And that's where we are headed with other BI platforms as well.
Nice. Yeah, it's awesome that everyone is kind of adopting this as a feature and pushing out to all of their customers too.
Yes, because everyone realizes that machine learning is the future.
Yeah, I think so.
And if we actually have talked to a lot of data analysts, and they all are taking courses on Coursera, and they're all reading up. And we believe the more tools we can provide to make the transition easier, the better it is, and the better the perforation of machine learning will be across the enterprises. And if you just think about your industry and think about some of the business problems, there are actually a lot of them which could be machine learning based. And what we have seen is, if you take retail, And if you say I can optimize inventory in a predictive way, I can predict which item is going to be needed in which region in what quantity, that actually you would think that it's only an efficiency play, but more than that, it's actually a customer satisfaction play as well.
Okay, how so?
Because now your customers in a particular region are not going to see longer shipping times. They're not going to see stock outs.
Yeah.
So there are a lot of operational supply chain, marketing, forecasting problems. Where just drawing a straight line from a historical trend is actually fairly inefficient. So if you could use machine learning for each of those, and some of our users are actually working with that data day in, day out, then that's going to have a great impact on the business metrics themselves.
Cool. So I think it's important to also touch on, since this is a brand new component of BigQuery, how to start getting started with it, how to get your hands on it. The exciting thing is that BigQuery ML is available today in beta, and so you can start using it today, start building your own models. Some great resources for getting trained. Obviously, watching this webinar helps, but it doesn't get you completely there. So there's some fantastic blogs that are out there. A couple particularly from a Googler named Lack. He has written some fantastic blogs about how to predict flight times. I think there's another one about predicting natality data sets, which are really awesome. So if you Google search Lack BigQuery ML, you'll find probably like 3 or 4 blogs on that specific subject. So I'd definitely give that a read. Secondly is there are courses already out there on BigQuery ML, and actually breaks down some of the necessary components around BigQuery, big data, machine learning, the concepts behind machine learning, because while we've made it pretty simple for our users, it's still important to understand how the machine learning actually works in the back end, different types of algorithms, stuff like that. And there's already a course on that on Coursera.com. So there are data insights course, which is pretty phenomenal. I've gone through that myself. And then obviously start getting your hands on BigQuery ML, start using it. And if there's any feedback that you have, go ahead and flood this email address here, the bqml-feedback@google.com. I'm sure that you're going to get quite a few requests for feature enhancements and stuff like that. And it's exciting that we can take some of those, the feedback from the community, and start building it out into actual products and stuff. And that's pretty much how BigQuery ML started. So that's really exciting.
Yep.
Cool.
And what we have seen is, if you know SQL, whether you use BigQuery or not, we have public data sets. You can go to the platform, get familiar within a few hours, and you can actually write your first model within another 2 hours.
Cool.
If you know it, it's 15 minutes to write your first model. Even if you don't, you go to our documentation and follow a tutorial, and within an hour or 2, you'll have your first machine learning model.
Awesome.
And that's going to be so exciting. The first time I did it, when I plotted the results, I was super excited to see how close it was to the predictions. Then I went back and tweaked the features, and it kept on getting better and better without me having to go learn Python, which is a tall task.
Or understanding all the linear algebra requirements that are in the algorithms for predicting machine learning. That's cool. Yes. That's very cool. Awesome. Well, Abhishek, I'm super grateful that you were able to join us with this. We're going to cut over to some of the questions that you guys have been asking live. So give us 1 minute, and then we'll be back to address your questions on camera. I'm sure there's going to be a lot of stuff about BigQuery ML, so glad to have you help answer those questions for us.
Delighted to.
Hey everyone, and welcome back. Thank you so much for all the questions that you've been submitting throughout the course of this webinar. We have 5 really awesome questions. I'm glad that you're here so that you can answer them for me. So I guess jumping right into it, does my data need to be in BigQuery to use BigQuery ML? I'm thinking like federated queries, that kind of aspect. Does the data actually have to be in BigQuery ML or BigQuery, or can it be external as well?
So you are right. We can federate from GCS today.
Okay.
So your data could be in GCS or BigQuery. The whole idea of BigQuery ML is that you bring ML to the data and you leverage the BigQuery's processing power. So your data for this to work has to be in BigQuery. Or if it's in GCS, we can federate and we can just get it in and use BigQuery ML.
Man, that makes it pretty powerful because you can query across multiple sources of data, therefore kind of eliminating the aspect of having different data silos.
Exactly.
So cool. Okay, on to the second question. How can we use BigQuery ML on unstructured data?
It depends on the unstructured data, what the data is. If you think about unstructured as short strings, say category of a user, etc., we one-hot encode them and you can use it directly.
Okay.
If you start thinking unstructured data as, say, pages and paragraphs and phrases,
Sure.
in that case, that data needs to be converted to a number for BigQuery ML to use. And to convert to that number, a typical process is to convert it into some kind of an embedding. Like an example could be you have a document and you use word2vec to convert it to a vector and embedding that knows which phrases are similar to which phrases. And then you can take those 2 points and you know that closer points are similar. And then you can feed those in to BigQuery ML as a feature. So to work with unstructured data that's a lot of text, you'll have to convert them into some embedding. And the embedding could be a traditional NLP technique like bag of words or TF-IDF. Or it could be something very advanced like word2vec, doc2vec. Or you could also call AutoML API or Cloud ML API, convert it into some structured semantics like which are the entities and what's the sentiment, and use those in BigQuery ML as is.
Yeah, that's an excellent point because BigQuery ML is not just, or is not the only machine learning platform within Google. So if you want to send some unstructured images, send them to the Vision API, videos to the Video Intelligence API, and you can get structured responses, like you said, sentiment, maybe identify the nouns, the verbs, the content of images, and you can place those in your BigQuery dataset and then query them with BigQuery ML. That's cool. That kind of ties everything together. That's awesome.
And as you think about some of the more advanced applications, like they found to do stock predictions better, you should also get some news into the model, right?
Yes.
Now, suddenly you can start seeing, once you go past just using structured data, how easily you can start getting in unstructured data to improve your model.
Cool. Awesome. Very cool. Okay, so jumping to the third question. How do I retrain the model with new data? That's a good one.
And that's actually how you would put it into production.
Okay.
So what we see is, depending on your use case, depending on how quickly your inherent data changes, customers retrain it anywhere from once a day to once a quarter. So you have to decide what the right frequency is. And since this is entirely in SQL, through the BigQuery API, you would use a scheduling platform, like we have Composer, which is based on open source Airflow.
Yes. Yep.
That would just call your create model query, point it to the new data, which could be written as a view, and just retrain it at the frequency that you chose.
Okay.
And then it waits for the model to be built, since you are calling it from the Composer API. And once it's built, you start using it for productions.
Okay, that seems pretty simple. Cool, okay. Number 4, can I export a BigQuery ML model for online predictions?
Yes, so exporting as a function is not provided out of the gate.
Okay.
But we do provide ml.weights, which you can use for feature inspection. So you can take the weights of the model and you can export it to your online infrastructure to use the model that way.
Okay.
So ML.weights is the way to export a model today and use it for online predictions. And talking about that, Lack actually wrote a blog on this particular problem as well. And in that blog, he walks through step by step on how you would set it up.
Okay, cool. And then final question, how does BigQuery ML pricing work? And I'm thinking in terms of like the slot usage and other aspects.
Yes. So BigQuery ML we have preview pricing right now since it's in beta. And BigQuery has two types of pricing structure. One is flat rate, where you buy a set number of slots, which are processing units, and on demand, where you pay for the data that you query. So for flat rate, during the preview pricing, we are going to include it with the current slots.
Okay.
So if you are already on flat rate, you use the same slots for BigQuery ML.
Okay.
And then you can mix and match your other jobs with ML jobs to get to a really good utilization. For on-demand, a prediction or evaluation is like a standard query. So that's $5 a terabyte.
Okay.
For model creation, during the preview, we are charging $5 a gigabyte. And the reason is, one, even though it's 2 lines of SQL, it's actually a lot of work underneath to get to a really good model.
Yeah.
And secondly, it's taking away a good 6 to 8 hours of infrastructure setup.
Yeah.
And that's the value that this is providing.
Yeah. Okay, that makes perfect sense. Cool. Well, fantastic. I'm glad you were able to get through all those questions. So Abhishek, thank you so much for joining us. I'm really thrilled to have you here. And for all of our viewers out there, thank you for joining the session on the BigQuery ML. Up next, we have a session around Google Slides, tips and tricks. So you'll definitely want to stick around for that. And until next time, I guess we'll see you later. Thank you.
It was a pleasure. Thank you.